Okay, this is lesson 3 for 8th grade math, and all we were doing today was working on addition and subtraction word problems. But before we dove into any of those, we started talking about some old solving strategies that we have been working on last year and probably in 6th grade as well. So the first thing we needed to do was talk about what an equation is. They've been seeing them their whole lives. Basically, an equation has an equal sign that shows that two quantities are equal to each other. Could be as simple as 3 plus 4 equals 7, or it could be a little bit more complex, like 5 plus 8 equals 9. Now, at first glance, all of my students know that 5 plus a equals 9, and that we need to figure out what a is. They should know that the reason that a is there is because we don't know what it is. We need to solve for it. Most will notice at first glance that we know that 5 plus 4 is 9, and that a would have to equal 4. And that is correct, but a lot of times in math we need to explain why we know that and show how we know that. So in an equation like this, we have to focus on, when solving, we have to focus on inverses to solve for variables, and we need to pay attention to the signs of everything that's in that equation. So we're trying to solve for a, and it looks like we're adding 5 to a. So the inverse of adding, if we remember from previous lesson, is subtraction. So what we're going to do is subtract 5 from this side, and that'll cancel out the adding of the 5. So those are gone. But what we do to one side of the equation, on the left here, we have to do to the right. So we have to subtract 5 from there as well. And that's where we get our 4 from. That's where we get a equals 4. Now, a lot of my students are having trouble realizing that when you do something to one side, you have to do it to the other. They realize that you have to, but they're not really sure why. So this was a scenario that I drew up. Let's think of a balance. And if on one side we have 5 plus a, and on the other side we have 9. Those right now are completely balanced, okay? If we're talking pounds here, let's say we want to get a by itself. That's the whole goal, to get a by itself. If we take our 5 pounds off on this side, well, this is going to go up if we don't take 5 pounds away on this side too. So if we subtract 5 over here, we have to do it over here as well. And then we would see that these would cancel. We'd be left with 4, and that a equals 4. So in order for this to be balanced, a would have to be 4, and that's why we have to do things on one side, or on both sides of the equation. So just remember, 2 rules when solving. We want to get that variable by itself, and whatever we do to one side of the equation, we have to do to the other. Alright. Just like I did in the previous example, I didn't box my variable, but I underlined it. I'm just going to go through these very quickly. A here, we're trying to solve for n, and what's happening to n? Well, we're adding 53. So what we're going to do is subtract 53 from both sides, and when we do that, we'll get 22. So here n is 22. Alright, same thing over here for b. Looks like we are adding a 26 to it, so we're going to subtract 26. So that all we have left is a. So a equals 35. And our last one here, we're going to want to add up all of our numbers first before we do anything. 3, 4, 7, 8. 3 plus 4 is 7. 7 plus 8 is 15. And if we add those together, we get 22. So now our new equation is n plus 22 equals 40. After we subtract 22. We will get 18. So n equals 18. And if we ever wanted to check any of these, we would just put whatever we get for our variable, plug it back in. If we got 22 plus 53, we should get 75. 35 plus 26 should give us 61. 18 plus 22 should give us 40. That's a way to check to see if you did it right. Okay. Now we're going to move on to subtraction real quick. Alright. Here's a simple one. A minus 3 equals 2. We should know that 5 minus 3 equals 2. How do we show that? Well, now we're subtracting. And we want to get this by itself. Okay? So what's happening to A? Well, we're subtracting 3 from it. So we're going to do the inverse of subtraction, which is add. And we got to do that to both sides. Gone. Left with A equals 2 plus 3, 5. Alright? Now we have another scenario with subtraction though. It's a little different than addition. Now, these equations kind of flip-flop. Now we're doing 5 minus x equals 2. So what's the variable? What's going on there? Well, we're taking the variable away from 5 this time. So whenever we have this situation, and until we get further along in the algebraic process, we're not quite there yet, we're just going to go ahead and say 5 minus 2 equals x. So, whenever we have this situation, when the variable is being subtracted, we do 5 minus 2 equals x. So, 3 equals x. Does that make sense? 5 minus 3 gives us 2? Yes. Alright. So if we try these real quick, they're just like the ones above them. P minus 24 equals 17. Well, this is this scenario. We're going to do that. And this. And we should get 1141. So P is 41. And same scenario here as it is here. We're going to just do 32 minus 14 equals x. 32 minus 14 should give us 18. 18 equals x. Alright? So moving on. Now that we know how to solve for a variable, now all we have to do is be able to set up the problems. Okay. Addition problems. You're going to start with sum, you're going to be adding more to it, and you're going to end up with a total. So our job is to figure out in the word problem, what is sum, what is more, what's the total, and also which one are we going to solve for. So if we look at this here, in the first half of the game, Heidi scored 12 points. In the whole game, she scored 27 points. How many points did Heidi score in the second half? Alright, well let's look at what we underlined here. 12 points, that's in the first half of the game. There's two halves. So that's our starting point, that's our sum. That's right here. Okay, our 27 points. It says in the whole game she scored 27 points. That's our total. So now we know that we're going to be solving for this part right here. So we can set up our equation now. We have sum 12 plus m equals our total, which is 27. If we use our inverses, we are adding to this. So we're going to subtract 12, and we should get m equals 15. So that's how we do that addition problem. Now a subtraction problem. Alright, this works well with money. You walk in with a certain amount of money, you pay, starting amount with your money, you're going to pay something, so you're going to take some away, and then you're going to get change back. So whatever's left. It'll be just like something like this. It says Alberto went to the store with a $20 bill. So he starts with $20. He bought a loaf of bread and a half gallon of milk. The clerk gave him $15.17 in change. How much did he spend? Okay. $20 bill. That is our starting amount. And the clerk gave him $15.17 in change. That is what is left. So we can set up our equation. We have $20 minus A, we're solving for that, equals our change, $15.17. Alright, this is just like one of the scenarios that we just saw. The variable is being subtracted, so we're just going to do 20 minus 15.17. So I'll do that quick. 9, 10, 3, 8, 4. So 483. And there we go. Alright, real quickly, we have a multiple choice question. The hike to the summit of Mount Whitney began from the upper trailhead at 8,365 feet. Okay? The elevation of the summit is 14,496 feet. So, the total elevation is this. That's our total. Which equation shows how to find the elevation gain from the trailhead to the summit? Well, that means we're looking for our gain, which will be G. Now, which one of these shows that? Well, our total is 14,496 feet. So we need that to be in our total. That needs to be on the right side of the equation. That eliminates C, it eliminates B. Now, which one of these is going to give us the right answer? Well, when we're looking at a total of something, we will go 8,365 plus what we gained to get our total. We're not going to subtract to get a total. We are going to go with A. And our last one here, if John F. Kennedy was elected in 1960 at the age of 43, what year was he born? This is a subtraction, 1960 minus 43. You'd be able to go through and solve that, and that's how we would set that up. Alright, so this was lesson 3 for 8th grade. The assignment is on the homework link.